So what we have here is a series circuit, and you can see in a series circuit the voltage is going one chain, one path. It's like our Christmas tree lights that we have, and when one Christmas tree light goes out, all of the lights go out. So on a series circuit, there's one path from power, the positive side, to ground, back to the battery. So it's going to go from the battery through these wires, through the loads, and it's transitioning all that power in a row. So on a series circuit, the way it works is we have a power supply, which is the battery, and we measure the source voltage of this battery from this power supply, and we just go from positive to negative, and we're about 13.79. And the voltage is dropped across each of these lights, and each one of these adding up will equal 13.79 volts. So if I go across the first bulb, and it's about 3.729 volts across that first bulb. Next, we go to the second bulb, and we measure across it, and it's about 3.484 volts. And then we go to number 3 bulb, and that's 3.239 volts. And then the very last bulb is 3.274 volts. So if I add each of these 4 bulbs up mathematically, that will total my source voltage. So I take this plus this plus this plus this to equal the source voltage. In a series circuit, what this means is voltage 1 plus voltage 2 plus voltage 3 plus voltage 4 equals total voltage. Okay, so that's the first principle of a series circuit with volts. Next, we're going to show you amps. So anytime I measure amps, I need to run it through the circuit. So I'm going to flip this to amps, and I'm going to physically remove the positive and move it to the fused amp right here. Whenever I measure amps in a circuit, I'm going to measure through the circuit. So I disconnect the terminal, and I'm going to put this on the battery, and then I run it through the circuit. You see the positive is going through the meter and then through the circuit. Anywhere I measure amps in a series circuit is going to equal the same amount of amps. So I have 0.042 amps, 42
thousands
milliamps. Okay, so if I decide to measure the amps here in the circuit, it should be the same amount of amps because we are measuring in series. And looky there, it's the same. So wherever I measure in this circuit, in a series circuit, I will get the same amount of amps going through the circuit. So in a series circuit, amp 1 equals amp 2 equals amp 3 equals amp 4. Using Ohm's law, measuring amps, I divide amps into volts to find out what resistance is. And mathematically, I could figure out what the resistance is. In this circuit, each of these bulbs have a resistance value. To measure resistance, I move it to the omega symbol, ohms, and I have to physically move this from the amps back to ohms here, and now I'm going to disconnect this from the power supply to measure resistance. So this has to be disconnected from all source power. And be careful, because whenever I touch these terminals, it can measure resistance through my body. With my thumb here and my thumb here, it's sending electricity through the meter, through my body to show what my resistance is. So whenever I measure resistance, I want to do it on something plastic or wood, and I can see what the total resistance is in this circuit. So this is 50.9 ohms of resistance in this series circuit. Now this is the total resistance. And mathematically, they're going to add up just like the volts. So there's 50.8. If I measure across this light bulb, you'll see we're about 12.2. I measure across this one now. I'm going to measure 11.8 to 12.7. And my last one here, 13.3. So resistance 1 plus resistance 2 plus resistance 3 plus resistance 4 is resistance total. So these are the principles of the series circuit. Voltage 1 plus voltage 2 plus voltage 3 plus voltage 4 gives me the total voltage, and it's dropped across each of the voltage loads, in this case the bulbs. Resistance adds up and current stays the same.